Hello everyone, welcome to course on digital electronics. This is the first video on digital electronics course, and this course is useful to all these branches, either diploma or engineering. In this video, I will discuss the classification of number system in very simple manner. Please take the screenshot of this page. I am not going to explain this slide. At the end of this video, I will tell you how to use this slide. A small request from my side, if you are new to my channel, please subscribe to my channel. If you feel this video is useful, then please like the video and share with your friends. Now I will start with number system. Most of the things in this world are represented in terms of numbers. For example, say 1 liter milk, 1 kilo grapes. And to consider another example, a real-time example, we'll visit a shop and we'll ask for give me 10 biscuit packets. Then he will simply give you the 10 biscuit packets. If not the case, if you ask like this, give me biscuit packets, he will immediately ask you how many. So in this way, in real time or everywhere, we are dependent on number system. Basically, number system is of two types, as I mentioned here. One is non-positional number system and another one is positional number system. We'll discuss one by one. First, we'll discuss about non-positional number system. The example for non-positional number system is ancient Roman number system. And here we use symbols to represent the number system. We don't use numbers to represent the number system. Instead, we will use symbols. In this system, we will use only 7 symbols. I mentioned all the 7 symbols here. Please have a look. And coming to here, I represents 1 and V represents 5, X value equal to 10, L represents 50, C represent 100 and D represent 500, M represent 1000. Today, Roman numerals are more commonly used in titles. For example, Napoleon 1, Napoleon 2, Elizabeth Rani 2, like that. Are using this non-positional number system for representing titles. Not only to represent titles, we are using to represent parts of work and on clock faces. This is the simple application we will find everywhere for non-positional number system. If you see on the wall clock or hand watch, some of the hand watches, you will see only these ancient Roman number system representation. We'll discuss a little elaborate about this topic, and if you observe here, different arrangements of these 7 symbols represent different numbers. For example, I value equal to 1, and if you want to represent 2, you have to arrange this I in this manner, and if you want to represent 3, you have to arrange this I in this manner, and you have to represent 4, you will use in this fashion. And these are the different arrangements, so that we will get 1 to 10 numbers. By using in this particular fashion, by arranging the symbols in this fashion, we will get these numbers. And how do we come to know about the final value of these symbols, or you can say forming the numerals? We'll have different steps, or you can say rules, to find the final value of that symbols, of the particular arranged fashion of symbols. We observe here step 1. Step 1 is equate the Roman numerals with the numbers. For example, as I said, X value equal to 10, L value equal to 50, C value equal to 100, D value equal to 500, M value equal to 100. First you need to equate that Roman numerals with the number value, number equivalent value. And step 2, add directly. Symbols are arranged from largest to smallest. For example, if the symbols are arranged in this fashion, MD, then you have to add directly. First, the M value is the bigger value and it is on left side, and the smaller value on the right side. So the symbols are arranged from largest to smallest. Larger one first and the smaller one next. So you simply add 1000 plus 500, which is equal to 1500. And another example, DL. D value is larger one and L value is smaller one. So you can simply add those two, which will become 550. And step 3, subtract. if symbols arranged smallest first and largest later. For example, ix. If it is represented or if it is arranged in this manner, then subtract from the bigger value 10 minus 1, which is equal to 9. And step 4. If a bar is over each symbol, then multiply it by 1000. Whatever may be the symbol. If the bar is present over, then multiply it with 1000. So here the bar is present over x, the value of x is 10, and because of bar we are multiplying it with 1000, so it will become 10,000. And we have exception for step 3. Let us discuss about that exception. Subtract if symbols arranged smallest first and largest later. It is the general rule. We'll see where it is applicable and where it is not applicable. Please read this statement. Example, I can only be placed before b and before x. The meaning of this statement is you can keep the smaller symbol, smaller numeral before the two closest numerals. For example, I. If you observe here the order of these numerals or symbols, this is the order. So if you want to keep this I, you can keep before B or X, that is first two closest symbols, and you cannot keep this I before L, or I before C, or I before D, or I before M. You cannot keep like that. You have to keep before first two closest. For example, here you can see I can only be placed before V. Then it will become IV, value equal to 4, and before X you can keep. Then its value become 9. This is one rule. This is one exception, and it can't be placed before L, C, D or M. For example, to write 49, you have to arrange those symbols in this manner. XL, IX. So it will become, for example, XL. X value is 10, L value is 50. Subtract from the bigger one, then it will become 40. And here IX, bigger one is 10 and smaller one I equal to 1. So value become 9. Finally it will become 49. To make it easy, you cannot represent like IL. Then I value is 1, L value is 50. So it will not become 49. This is what you need to remember. And you can only place one smaller number in front of one smaller numeral in front of a larger one for subtractive purpose. For example, the correct way to write 7 is 5II, not IIIX. You cannot use the correct way to write 7 is 5BII, and you should not write in this manner IIIX. The way of representing 7, the correct way of representing 7 is, this is the correct way, and you cannot represent in this fashion. Only one smaller numeral in front of a larger one for subtractive purpose is allowed. These are the rules for writing these are the rules and steps for ancient Roman number system or non-positional number system. Now we'll move to the another type, that is positional number system. Positional number system uses digits for representation. But in case of ancient, we are not using digits, but we use symbols. But in case of positional number system, we use digits, and positional number system is most widely used number system. Positional number system again we classified based on the number of digits available in the system. For example, if total number of digits are 10 digits, then we call it as a decimal number system. If the total number of digits are 2, then we will call it as a binary number system. If total digits available are 8 digits, then we will call it as a octal number system. If total digits are 16, then we will call it as hexadecimal number system. Specifically speaking, the digits, 10 digits may be 0 to 9. Then we will call decimal number system. 2 digits, only 2 digits are present. Those 2 digits are 0 and 1. Then we will call it as binary number system. And if the 8 digits are present from 0 to 7, then we will call it as octal number system. And if 16 digits are present, that is from 0 to F, then we'll call it as hexadecimal number system. About each type in positional number system we'll discuss in the second video in elaborate manner. And this is the end of this video. And coming to first slide, here I said just have the screenshot of this slide, because now whatever I presented in this whole video, please try to make it very simple in this single slide, so that it will become easier to memorize and easier to remember. So please cover the entire video in this single page like short notes. Thank you for watching.